Good morning all. In previous class we have seen the pin diagram of the 81. So in this class let's see deliberately what are the functions of the each pins. Crystal 1 and crystal 2. The 8051 has on-chip oscillator but it requires external clock to run it. That is why we are using a quartz crystal oscillator in between the crystal 1 and crystal 2. The quartz crystal oscillator also needs two capacitors of 30 picofarad value. So this is the block diagram of the quartz crystal oscillator connected to the 8051. And instead of a quartz crystal oscillator we have one more oscillator option to connect it between crystal 1 and crystal 2, that is TTL oscillator. In the same way TTL oscillator is connected in between crystal 1 and crystal 2 to support the oscillator. So the speed of 8051 is calculated by the frequency provided by the oscillator. So that frequency is calculated by the CRO or the oscilloscope by connecting the crystal pin with CRO. So based on the frequency, the clock frequency of the oscillator will be calculated. Next one is reset pin. So the reset pin is an input pin and it is active high. So generally low, but when we making the reset pin to active high, it will reset and terminates all the activities running in the microcontroller. So this is often referred to as a power on reset. Activating power on reset will cause all the values in the resistors to be lost. In order for the reset input to be effective, it must be have a minimum duration of 2 machine cycles. In other words, the high pulse must be high for a minimum of 2 machine cycles before it is allowed to go low. That is why we are connecting 11.059 MHz crystal frequency in between X1 and X2 to provide a high pulse of reset signal to the 8051. Next one, external access. So external access means we are connecting the external code and data memory to the 8051. So we have an external code data and memory. So when the external access is connected to the VCC, that means it stores the external code and data memory. When it is connected to the ground means the data is stored externally to the devices. The code and data are stored externally in the devices. Next one, PSEN and ALE. PSEN means program store enable. So whenever the program store enable is equal to 0, it has the access of external code memory. Whenever the PSEN value is equal to 1, it has the access of external data memory. So this pin is connected to the OE pin of the external memory, and the ALE pin is nothing but it is used to demultiplexing the address and the data which is available in the port 0. Next one, input output port pins. There are 4 8-bit input output ports available in the 8051, that is P0, P1, P2 and P3. Each has a 8 pins for the input and output devices interconnections. All the ports upon reset are configured as output, ready to be used as input ports by the external devices. First, port 0. So port 0 is also designated as AD0 to AD7, that is address and data both are multiplexed together and communicated through the same channel. When ALE indicates if P0 has address or data means ALE equal to 0 means it provides data D0 to D7. When ALE equal to 1, it has address A0 to A7. Next one, port 1 and port 2. Compared to port 0, the port 0 is connected with the external memory. But port 1 and port 2 has no connection with the external memory. So it has a connection with only input and output devices. Next, port 3. Port 3 has some special features that are used for serial communications. Some ports are used for external interrupts. Some ports are used for timers, and some ports are used for read and write signals of the external memories we have connected. So the functions of each pin and the respected pin are tabulated here. Next one, the summary of the pin description. So VSS or ground, that is in one of the input type, that is 0 voltage. VCC is an input type that gives the power supply to the 8051, that is normally 5 voltage. P0 to P7, that will act as an input and output, mainly for to connect the external program and data memory. P1 and P1 to P17, P2 to P2.7. So both are input output devices that has the application of interfacing input and output devices. P3.0 to P3.7 is the input and output devices that has some special features to serve. Reset pin, when the reset pin is high with the 2 machine cycles, it resets all the activities by the devices. ALU, address latch enable, that is used for demultiplexing the address and the data of the memory device. Program store enable is used to connect the control and data memory signals. External access enables the external memory devices to interconnect with the 8051. So this is the basic general block diagram of 8051. So all the blocks are directly connected with the CPU. See, ROM, RAM, the timer signal, serial port, input output ports, and a bus control all are having the direct connection with the CPU through this bus, and also the CPU has an interrupt control and an oscillator. And this is the detailed architecture of the 8051. In this we will see the basic registers, basic arithmetic and logical unit, some special function registers along with the timers, port 0, port 2, port 1 and port 3. Here is the oscillator circuit. So these are all the blocks connected with the 8051. This is the detailed structure of the 8051. Okay, in next class we will see the various addressing modes of the 8051. Thank you.